This activity allows for students to measure the wind speed and interpret their data on the Beaufort scale. To begin this activity, the teacher may want to explain how the Kestral works.
This is a Kestral wind meter. Scientists use this in the field to measure wind speed. In this activity, we will be using a couple different options on this device. We want our device to be set to maximum. You can scroll through the different measuring speeds. You can go maximum, average, or spontaneous. And we want it in miles per hour. And to change it, the units, you hold the middle button down and click the right. So we want miles per hour and maximum speed.
Now allow the students to measure their wind speed and guide them through the use of the chart.
So how windy am I? 34.5 miles per hour.
Now go ahead and find your wind speed on this chart.
Okay, so how windy am I? I was, 34.5 miles per hour. That puts me down here. I am a moderate gale. If there were more of me, and we all blew at the same time, we could put trees in motion. Over here.
This number represents the Beaufort scale. So we can classify your wind speed between a range of 32 to 38 miles per hour, and we would classify it as a 7 on Beaufort scale.
Please take a moment and answer the questions. Why don't wind turbines work with too little or too much wind?
And the answer is, we were a 7.
Yes, we were.
32 to 38, moderate gale, and that's in the bright green area. Do you want to explain about these different colors?
Yeah, well, as you can see, there's a red area, 2 red areas, one at the minimum and maximum of the Beaufort scale. Why do you think we'd have a red area at the minimum area?
I think that one's easy to know, that it just doesn't have enough power at that point to make the turbine spin. Those blades are pretty big, so it probably doesn't start, or as we say, cut in, until it gets at least to this first green one, which is what's the range there?
8 to 12 miles per hour.
Ah.
Now what about the other end of the spectrum? What about the high winds?
You know, those are really expensive machines. The last I heard, they were about $1 million per megawatt. So those are pretty expensive machines, and you would not want them to be damaged. And so I would suspect that when the wind gets really, really bad, they're going to shut them down because they want to protect them. So I see that that's what we've got right here, where we call this the cut-in speed. This is the cut-out